Which of the following sets correctly show all possibilities for the product of two irrational numbers? Before we start this problem, we want to make sure we carefully read the question and identify the important terms used in it. Since we are to correctly identify all possibilities, we're looking for accuracy, and we're also looking for all possible answers in regards to the types of products we'll get from these two numbers. Now, it says product. Product means that we're looking at two numbers that multiply together. We also see two irrational numbers. An irrational number is a number that results in a non-terminating, non-repeating decimal. For example, when we have a number that's non-terminating, non-repeating, that means that it goes on forever and it doesn't have a repeated number or a pattern within that decimal. So usually we see this by the ellipse, the dot, dot, dot behind the number. But other forms of an irrational number could be like a root of a number that we would call like a non-perfect root. So like a non-perfect square when we're doing a square root of a number, such as the square root of 50. Or maybe the cube root of 30. When we actually do those in a calculator, you'll see a decimal form, and what that creates in that decimal form is that non-terminating, non-repeating number. And the last form that you might see that irrational number in would be like pi in any kind of form. So with that in mind, let's go ahead and look at answer choice A. In answer choice A, the first problem we see is 1/8 times the square root of 20. So we do have the product. However, 1/8 does not match the properties that I just described with two irrational numbers, with an irrational number. It's not the square root of a non-perfect square or anything like that. It's not a non-terminating, non-repeating decimal, and it's definitely not pi. So therefore, 1/8 is actually a rational number. So this doesn't even show the product of two irrational numbers. So let's move on to B. In answer choice B, we see 0 times the square root of 40. 0, again, does not match the properties of an irrational number. Therefore, it's a rational number. So now we're looking at a product here of a rational and an irrational number. That's not what the question is asking for. So again, it cannot be answer choice B. Let's look at answer choice C. Answer choice C, we have the square root of 8, which is irrational, times the square root of 32, which is also irrational. So we do have the product of two irrational numbers here. However, it is good for us, since we're looking for something that correctly shows or accurately shows, we want to actually do the math to check the square root of 8 times the square root of 32 to make sure that it actually does equal 16. Now, suppose you don't have a calculator for this, you can actually do this by hand. And so what we're going to start with is the square root of 8 times the square root of 32. Whenever you multiply two radicals together, you can actually, as long as they have the same root, in which they do, the root would be 2, you can actually combine the terms underneath the same radical. So here we have 8 times 32. Now what we're going to look at is that we usually look at, if we're going to solve this by hand, the prime factorization, getting it down to the prime numbers that all multiply together. However, we can kind of take some shortcuts here. For example, let's leave the first 8 alone. But think about the number 32. The number 32 is actually the product of 8 times 4. And what I see here is a set of twins, is what I call it. The 8 and the 8 match, so we can actually leave those there. Now let's continue on. If we were to say we've got the square root here, we're going to bring down those two 8s that match. Let's break down that 4. 4 is the product of 2 and 2. So now what I see is another set of twins. So the 2 and the 2 would be what I call twins. Well, when you take them out of the radical, because you have a set of twins, you only get to keep 1. So how many 8s do I get to keep? You only get to keep 1 of them. How many 2s? Only 1 of them. Let me tell you why. If we actually did 8 times 8, that number is 64. The square root of 64 is 8. If we did 2 times 2, that number is 4. Again, the square root of 4 is 2. So when we pull both of them out, what we now have is 8 times 2, which is 16. That matches the problem that they've shown to us. So far I have the product of an irrational number, 8, times an irrational number, square root of 32, equals 16, which is a rational number. So the square root of 8 times the square root of 32, both of those irrational, equals the rational number. Now, let's look at the second one they give us. The second one they give us is pi. Pi is irrational times the square root of 27. That is also irrational. Let's take that square root of 27 and let's simplify it, because obviously that's what they did on the right. When you think of 27, that would actually be 9 times 3. Now we can break this down even more. Square root of 9 times 3 can also be written as 3 times 3. That product is 9 times the remaining 3. You circle your set of twins, you can pull it out. And when you do that, you pull out just 1, because the square root of 9 is just a single 3. Square root of 3. So if we put that together with the pi that they started with, pi times that square root of 27, what that gives us is that 3 square root of 3 times pi, which we usually put right next to the number. So this does match, again, the solution that they've given us in answer choice C. So let's look at what we have here. We have an irrational number times an irrational number. So pi is irrational times the square root of 27 is irrational. And their product actually results in another irrational number. So the possibilities for the product of two irrational numbers, as we've seen in these two examples, is actually that they can be both rational or irrational. The possibilities require that they both can happen. So let's just double check answer choice D just to confirm our answer that we believe is C. On answer choice D, we have the number 3/9 times the decimal 2.1 repeating. Both of those numbers are rational. So it's not even showing us the product of two irrational numbers, they're showing us the product of two rational numbers. Already, we can cancel out answer choice C. So the answer choice for question number 1, that is the correct solution, is answer choice C.